Good morning. Today is June 3, 2020, and our subject is Electric and Electronics Fundamentals 3. Our topic for today is sinusoidal alternating current frequency measurement. And for this topic, we are going to have activity in which the objectives are the following. Number 1, to perform the actual frequency measurement of a sinusoidal alternating current and compute for the oscilloscope given the time of the sinusoidal waveform. So, of course, in this activity, we are going to use the oscilloscope and the function generator. So this is the source of our sine wave, and then of course we have here frequency of 60 Hz. I presume that you already know how to use and perform basic operation of oscilloscope, like adjusting the volt per division and time per division and calibration. So this one, of course, is a function generator. So you should know how to set, for example, the frequency. So you can adjust here, and then the output peak voltage. So you can adjust here. So, but before we proceed, so again, let us review some of the parameters of a sinusoidal waveform. So in our previous activity, so we measure the B maximum and then the B peak to peak as well as the B RMS. For today, we are going to use the this one, the time. No? So for example, this one cycle is considered as the time for this particular waveform. So for up from this starting point up to this point, which is 360 degrees, so this is considered as one cycle, and from this point up to this point, that is the period or the time of one cycle. So let's say this is 1 second and this is 1 cycle, so that is equal to 1 hertz. Or let's say there are 2 cycles, and in 2 cycles it is 1 second, the period is 1 second, or the time, so that is considered as 2 hertz. So that's why in here you have 60 hertz, so meaning there are 60 cycles in 1 second. Or let's say 100 hertz, so there are 100 cycles in 1 second. So this is the cycle, and this is the period or time of 1 cycle. So this one. Okay, so in order to know that, so let us now try to measure the time. No? So the time. Of course, you have to connect this output here. So we have here 60 hertz, and then this is the output of the function generator. I connect it to the probe of the oscilloscope, and this one. So as you can see here, we have here the time, no? So I will stop. So this is the time, 16.67 millisecond. So you can see here 16.67 millisecond. So that is the time or period of 1 cycle. And then we are going to write here the answer. So time is equal to 16.67 millisecond. So how about the frequency F? Of course, we are going to use this oscilloscope. So we need to set the oscilloscope to measure the frequency. So I will put here. So this is of course this one, add measure, then add measurement, then of course frequency, then okay, add. So as you can see here, so let's stop. This frequency is 60.12 hertz. Okay, so you see here, so it is 60.12 hertz. So right here, 60.12 hertz. So this is the result. This is the result. So the time is 16.67 millisecond, and the frequency is 60.12 hertz. So let's try to draw the waveform. So from here, okay. So let's try to draw the waveform. 1 second. So 1, 2, 3, 4. 4 boxes. So from here, starting point 1, 2, 3, 4. Okay, so this is the waveform. So you have 1, 2, 3, 4. So 4 boxes in 1 cycle. So now, as you can see here, we're able to get the time for one period, which is 16.67 millisecond, and the frequency from the reading of oscilloscope is 60.12 hertz. Now, let us try to compute using the formula. So, let's try to compute using the formula. F is equal to 1 over time. And we are going to use this time. T is 16.67 millisecond. So, F is equal to 1 divided by 16.67 millisecond, or that is 1 divided by, so you have to convert to second, 0.01667 second. So we need to convert this millisecond to second, and we are going to use calculator to compute for this. So what will be our frequency or computed frequency? So you know how to convert millisecond to second, so you just divide this by 1000. So we have here is a calculator. So we have 1 divide 0.01667. See here? Okay, so that is equal to, see answer? See, 59.98 hertz. 59.98 hertz. 59.98 hertz. So, as you can see, we have here the time and then the measured frequency using oscilloscope, and then you have the computed value. And then based on our result, the reading and the computed value are almost the same. So in this activity, we're able to prove that the measured and theoretical value or computed value are almost the same. Although there is a very small difference, so it is acceptable. So I hope you understand our activity. So this is of course the measurement of the frequency of a sine wave. So the frequency, again, the frequency is the number of cycles in 1 second, as I've explained in my previous discussion. So in our introduction, so that is frequency, that is the cycle per second. And in this activity, we're able to achieve our objective to measure the actual frequency and compare it with the computed value using the oscilloscope. So let us try to do this one. Okay, you can use 100 Hz for example. So 100 Hz, and then try to compute here the time. So time is equal to 1/100, or this one. You can use this space to compute for the value. So let's try to use 100 Hz and then compute for the value. So thank you very much. I hope you understand and able to grasp the lesson for today, and try to practice and analyze the lesson, and hope you will understand it and appreciate. Good day, Group A, C, and D, and this is Mr Red.